Okay, today we're going to look at some patterns in exponents to help us solve when you have an exponent of 0 or you have a negative exponent. So let's go ahead and start with what we know. We know that 3 to the 4th is the same thing as 3 times 3 times 3 times 3, which is equal to 81. We also know that 3 to the 3rd is the same thing as 3 times 3 times 3, which equals 27. What I noticed from 81 to 27, how did I get from 81 to 27? If I take a look, I know that 27 is 1/3 of 81. So that means I divided by 3. 81 divided by 3 is 27. Let's take a look how 3 to the 2nd fits. 3 to the 2nd is the same thing as 3 times 3. Now I know 3 times 3 is equal to 9. If I wanted to get from 27 to 9, I again would divide by 3. We're starting to find a pattern here. Notice that this 3 to the 1st power is the same thing as 3, which is 3. In order to get from 9 to 3, I again divide by 3. So what do we do with 3 to the 0 power? Well, I don't have any 3's here, so let me go ahead and take a look at what would I do with my 3. So if I've taken 81 and divided by 3 to get 27, then I divided by 3 to get 9, then I divided by 3 to get 3. Now I'm going to divide by 3 again. What is 3 divided by 3? It's 1. So 3 to the 0 power is 1. It's hard to think about that, but it is. 3 to the 0 is 1. So our rule is going to be any number to the power of 0 is always going to be equal to 1. Let's see if that works. Let's make another little chart over here. What if I were to have 4 to the 3rd power? That would be 4 times 4 times 4. 4 times 4 is 16. 4 times 16 is 64. What about 4 to the 2nd? 4 to the 2nd is 4 times 4. 4 times 4 is 16. Now I notice to get from 64 to 16, I divided by 4. What about 4 to the 1st? Well, 4 to the 1st is just 4. To get from 16 to 4, I have to go 16 divided by 4 to get 4. So notice my pattern now, I'm dividing by 4's. So if I have 4 to the 0 power, I would have to take my 4 here and divide by 4. And what is 4 divided by 4? It's 1. So notice that 4 to the 0 power is 1. Any number or variable to the power of 0 will always equal 1. Now what happens if we keep going? We've noticed that there are sometimes negative exponents. So notice on my exponents, I went from 4 to 3 to 2 to 1 to 0. What would come next? Next, I would have 3 to the negative 1. Well, what do I do with 3 to the negative 1? Well, let's take a look at our pattern over here. Each time I'm dividing by 3. So now I'm going to take 1 and I'm going to divide it by 3. I'm going to write it exactly like I say it. That is 1 divided by 3. So 3 to the negative 1 is the same thing as 1/3. Let that sink in for a minute. What happens if I have 3 to the negative 2? Well, I'm going to continue to follow my pattern here. I'm going to divide by 3. I'm going to take 1/3 and divide by 3. Now just to remind you, if I have 1/3 divided by 3, that is the same thing as 1/3 times 1/3, which in this case is 1/9. So my answer is 1/9. So notice that each time I change my exponent to a number 1 less, I have to divide by 3. I want you to think about these numbers right here. Okay. Notice that 1 to the third power is the same thing as 1 over 3 to the first. And 1/9 is the same thing as 1 over, what is 9 again? Remember, 9 is 3 to the second power. So there is a rule here. If we have a negative exponent, we can convert it to a positive exponent by dropping it to the denominator. So let's go ahead and take a look at our rule right here. A negative exponent can be rewritten with a positive exponent. So if I have 3 to the negative 2, I can make it positive by writing it as a fraction, 1 over 3 to the second. I take my negative 2 and I convert it to a positive exponent. I do that by dropping it to the denominator. If I have 5 to the negative 3, I'm going to take my 5 to the negative 3, I'm going to drop the 5 to the third power to the denominator, and it becomes positive. Notice that my negative 3 becomes a positive 3, but now it's in the denominator. What happens if I actually have a negative base, like negative 3 to the negative 2? Well, only the exponent changes. So I'm going to drop this to the denominator. I keep my negative 3, but my negative 2 becomes a positive 2. Now the reverse is also true. If I have 1 over 3 to the negative 4, I can turn it into a positive exponent by flipping it back up to the denominator, and this becomes 3 to the positive 4. If I have 1 over x to the negative 5, I can make it positive by flipping my fraction, x to the positive 5. And one last thing, remember we already learned that any number or variable to the power of 0 is 1. So let's go ahead and take a look at an example. If I have 3 to the 0, we know it's equal to 1. If I have x to the 0, it is also equal to 1. I could have the number 3,562 to the power of 0, and my answer is 1. So just remember, anytime you have the power of 0, your answer will always be equal to 1. And those are two patterns that we've used in exponents today.